right, this is section 9.1. Did you record, sweetie? This is section 9.1, vertical asymptotes. Tonight's homework is page 586. We're going to do numbers 19 through 30. And I would like to remind you of a golden rule in mathematics. You can never, ever, ever, not even on Sundays, divide by what number? 0. So the 0 can never be in the denominator. Not even on days of miracles when the Dolphins beat the freaking Patriots is that ever possible. It's never going to happen. You're never, ever going to be able to have a 0 in the denominator. In other words, for some of us, we like to remember that you can never divide by 0. That's never going to happen. So why we care about this is because sometimes we have graphs and we have scenarios in our life where the denominator might be 0. Isaiah, can you move your chair so I can see your face, honey? Can you scoot up? Keep going. Grayson, can you see or do you want to move up? You can move up. Like in this scenario here, what I want to do is highlight, please, the denominator. And just like you did in the warm-up, we're going to plot some points and see what happens. Let's make a table here. Put in -3, -2, -1, 0, 1, 2, 3, and I'll even go to 4 and 5. Now this whole function equals y. Now we're just going to plot in some points. So I plug in -3 here, -3 minus 2, that's -5, so that's going to be -1/5. If I plug in a -2 here, -2 minus 2, that's -4, so that's a -1/4. -1 minus 2, that's -3, so that's -1/3. Plug in a 0 here, 0 minus 2, that's -2, that's -1/2. Plug in a 1 here, 1 minus 2, that's -1. 1 divided by -1 is just -1. And look what happens when we plug in 2. What do we say the denominator is never allowed to be? 0. What happens when you plug in 2, though? You get 0. Well, what's 1 divided by 0? We call that undefined. Plug in 3. 3 minus 2 is 1. 1 divided by 1 is 1. 4 minus 2 is 2. That's going to be 1/2. And 5 minus 2 is 3, so that's going to be 1/3. Let's go ahead and plot these points. Call this 1, 2, 3, and -1, 2, and 3. And we're going to go ahead and start plotting these points. So negative 3, negative 1/5. So that's negative 3, 1, 2, 3, negative 1/5. That's like not even. Like if this is 1/2, it's even less than that. Negative 2, negative 1/4. So it's just going to be a little bit lower. And then negative 1/3. And then 0 is at negative 1/2. And then 1 is at negative 1. And 2 is undefined. Where do I put the dot for undefined? Is there going to be a dot at negative at 2? No. So what we can create, you guys, is that you're telling people nothing exists at negative 2. So what you do is we create what's called an asymptote. So at x equals 2, there's an asymptote. Let's go ahead and finish plotting these points. 3, 1, that's 3 and 1. 4, 5. 4 is 1/2. 5 is 1/3. So what you see is happening, ladies and gentlemen, is all these points are very much attracted to the asymptote, but is never going to touch it. It's kind of like a magnet. I want you to imagine like a magnet or an electric fence. Your points are going to lean towards it, but never touch it. Like this. And then we're going to put arrows on the end. So do you see why in the warm-up, why I asked you to plug in a bunch of points? What do you have to be really good at so this is not hard for you? Did you have to be really good at plotting points? Yeah, but what's the most important thing? If these points are wrong, what's going to happen to your graph? They're all off, right? Which is why on our warm-up, it's really important I know how to plot points without having any hesitation, really. So tonight's homework, I'm asking you, where's the vertical asymptote? You should be able to tell me based on the denominator. Did I even care about the numerator for the asymptote? What's the only thing that's not allowed to be 0? The denominator. Can the numerator be 0? Yeah. Can you do 0 divided by 4? What's that? 0. Can you do 0 divided by 100? What's that? 0. The numerator can be 0. But can the denominator be 0? No. So if I want to find my vertical asymptotes, I just need to pay attention to the denominator. Okay? Let's try another one. Example 2. Let's say f of x is equal to negative 1 over x minus 4. I'm going to go ahead and highlight where my vertical asymptote is going to be, which is going to be at what? What's going to make my denominator 0? How do I know what makes my denominator 0? Set it equal to 0. Very good. So my step 1 is to set my denominator, sorry about that, set my denominator equal to 0. And I'm going to solve to find my asymptote. And I'm going to put the word asymptotes just in case, because sometimes the denominator can have multiple asymptotes. Okay, so what I'm going to do is I'm just going to write my directions on the right, and I'm actually going to do it on my left. Can you use my white outline? It's behind that can. So I have x minus 4 equals 0. That means x is equal to 4. This is my vertical asymptote. Next thing I want to do is plot points to the left and to the right of the asymptote. So let's say I have my table here. Here's my x, here's my y. My asymptote is at 4. What's going to happen at 4 again? What happens here? It's undefined. Very good. So I know that's where my asymptote is. We're going to do at least 3 points to the left of 4 and at least 3 points to the right of 4. I'm going to do 4 to be safe. So what's before 4? 3, 2, and 1. And I'm going to go to 0. And then let's do 4 after 4, which would be 5, 6, 7, and 8. Can you guys plug in those points for me and tell me what you get? I'm going to put it in decimals this time because some of us prefer it, but you should be able to speak both languages, decimals and fractions. So you should have gotten 1/4 for the 0, which is 0.25. This is 0.33. This is 0.5. And 3 is just 1. Did you guys get that? And then down here is kind of the mirror image of it. And when I say kind of, I mean exactly. Except it's negatives. I wonder why that is. I wonder if that asymptote has anything to do with the fact that these numbers are pretty much mirror images of each other. Daisy, don't let me lose you, babe. Hang in there. So that was step 3. Step 4 is to obviously just graph it. I would always graph the asymptote first. That's a huge hint. My rookies just try to start from the top and bottom and usually make a mistake. So I always start with the asymptote. Isaiah, hang in there. Stick with me. And then I would graph the points. So if I want to graph this bad boy, I notice that I don't really have anything on the negative side. So I don't really need to have a negative. I mean, I don't have negative 1, 2, 3. I didn't even plug in those points. So I really just need to heavily emphasize the right-hand side. That's what I graphed. And I went all the way to 8. 3, 4, 5, 6, 7, 8. And my asymptote is at x equals 4. So 1, 2, 3, 4. And 0 was at 0.25. 1 is a little bit higher. 2 is even higher. 3 went all the way to 1. So my graph is never going to touch it, but it's going to lean towards that asymptote, but never cross it. 5 is at negative 1. 6 is halfway there. 7 is even closer and closer. And again, it's never going to touch that, but it's going to lean. What do you guys think? So far, so good? Talk to me, please. Are we okay? All right, we just need to go a little bit faster. So there's other examples we need to go through. Just refer to our process here. Example 3. Let's say I have f of x is equal to 1 over x minus 3 squared. Again, my first step is to set my denominator equal to 0. So here's my denominator. X minus 3 quantity squared equals 0. So I'm going to take the square root of both sides. That's x minus 3 equals 0, because the square root of 0 is 0. So x equals 3 is my vertical asymptote. And I make a table. 3 is my asymptote, so I'm going to plug in 2, 1, 0, and then 4, 5, and 6. 3 is my asymptote, and it's undefined. For the sake of time, I'll just let you know what these are. This is 1 over 16. This is 1 over 9. This is 1 over 4. Sorry. Let me do that again. When I plug in 0, I get 1 over 9. 1 is 1 over 4, and 2 is just 1. And then if you plug in 4, you get 1 again, and the mirror image, this is 1/4, and then this is 1/9. This time it's not going to be the negatives because it's squared. Whenever you square a number, it stays positive, right? So all we have to do now is graph it. Again, I really only plugged in positive numbers, so I'll go ahead and draw my asymptote from the beginning, which is at 3. When I graph it, God bless you, it looks like this. Here's your doyo. Please graph f of x is equal to -1 over x minus 2 squared. So you'll notice for the doyo that you have an asymptote at 2, and that both graphs are in the negative, because once you square a number and then multiply it or divide it by -1, that both numbers are going to be negative. That's why they're both on the bottom. All right, example 4. If I ask you to identify the asymptotes, we're going to just do that first step. We're going to set the denominator equal to 0. So I have f of x is equal to 3x over x squared minus 4. Today we're only doing vertical asymptotes. Tomorrow I'm going to talk about horizontal. So the only thing I care about tonight is the vertical asymptotes. So I'm going to set x squared minus 4 equal to 0. That means x squared is equal to 4. That means x is equal to plus and minus 2. That means you have an asymptote at 2, and you have another one at -2. So you have 2 vertical asymptotes. Part of tonight's homework is for you to just identify the asymptotes. Another example might look like this. Example 5. Isaiah, I need to catch up, babe. Catch up. I want you to identify the asymptotes. say I have f of x is equal to x over x squared minus x. Again, the only thing I care about for vertical asymptotes is what? Talk to me, please. The only thing I care about for the vertical asymptotes is the denominator. So I'm going to set the denominator equal to 0. Here I'm going to factor out x, and I'm going to get x minus 1. So I have the zero product property, which tells me that x is equal to 0 here. And then x minus 1 is equal to 0, so the other one is x equals 1. So my two vertical asymptotes are 0 and 1. If you're never sure, you could always check. You plug in 0 here. 0 squared minus 0, yep, that's 0. 1 squared minus 0, that's 0. So if you get stuck at this part, how would I solve? Well, you're going to need to factor. You guys, factoring is life. We've been factoring all year long for a reason. Don't forget what we've been doing this entire semester. Example 6, you might see it like this as well. X minus 2 over x minus 2 and x plus 3. Again, you're going to set the denominator equal to 0. So that's x minus 2 equals 0, and x plus 3 is equal to 0. You don't have to multiply it out. It's already done for you, so you just factored for you. So x equals 2, and x equals negative 3. Now, the reason why this problem is special is that you'll notice that there's an x minus 2 on top and on bottom. When you have them cancel out like that, we call that a hole in the graph. A hole happens when something in the numerator cancels something in the denominator. So how would you answer this question? You would say there's a vertical asymptote at x equals negative 3, and then there's a hole at x equals 2. Because the x equals 2 got canceled on top and bottom, so it's not an asymptote, it's a hole now. Let me give you another example of a hole. So example 7. If I have x minus 3 on top and then x squared minus 9. Well, this factors to x minus 3 on the top, and the bottom factors to x minus 3 and x plus 3. This is why I have to be really good at factoring, because I'm going to have to factor pretty much every single time if it's not factored for me. What do you notice is on top and bottom? 3. So is it a vertical asymptote or is it a hole? So we're going to have a hole where at x equals 3 or x equals negative 3? Careful, x equals 3. Okay? So I have a vertical asymptote where you can't just put negative 3. You have to put a letter. X. Very good. X equals negative 3. And you have a hole where? At x equals 3. Here's your doyo. I want you to find vertical asymptotes and holes. The answer to both of these is none. You set the denominator equal to 0. Don't you get x squared plus 3 equals 0, so you get x squared equals negative 3, so x equals plus or minus I rad 3. That's not even real.